Alright, so this is the hydrate problem, and I've been getting a lot of questions on this one, so let me just shoot out a quick video. The first thing is, on all hydrate problems, you're going to have a T-chart that has the dry anhydrous compound, which would be COCl2. So you need the grams of this cobalt 2 chloride by itself, and you're going to be changing that to moles of COCl2. Your second T-chart that you're going to get is going to be grams of H2O and the mass of water is this. So for every hydrate problem, you're going to have this T-chart, and you're going to have a T-chart with water. So the ionic compound, and then you're going to have the T-chart for going from grams of water to moles of water. So the first thing we've got to do in this problem, since they didn't give us the mass of water, we have to calculate the mass of water. So what you want to do is you're going to take this number minus this number, because when you subtract those two, you get the mass of water that evaporated off. And when you subtract those two numbers, you should be getting 0.74 grams, and that's of H2O. So we're going to put that right here. Okay. For the first table there, you are already given the mass of the dry cobalt 2 chloride. It's given to you right here without the water. So you want it dry, no water. So this has no H2O on there. So that's the amount that starts off this chart. That's a decimal. Sorry about that. Alright, so then we have to calculate the molar mass of cobalt 2 chloride, which when you do that, I believe this is what you get. So cobalt was 58.93 plus 2 times the mass of chlorine, which is 35.45. Should give you that. So when you divide that out, you get to get moles for each of these. 6, 7, 8 moles of COCl2, and on this one you get 0.0411 moles of H2O. Those units cancel each other out, so you're just left with moles. You're going to divide through by your ionic compound each time, its molar amount. So this gets us a value of 1 for this, and when you do the math on this one, I shortened my numbers. Let me just double check my math. 0.0678. You get 6.06, so that rounds off to 6. So this 6 is what goes in front of H2O. So the formula for this one is COCl2. This 1 is understood in front of the COCl2 right here. That 1 is understood to be there. We don't write it in, but it's just understood to be there. Hang on, my 2 doesn't one right. Alright, so this means for every 1 mole of COCl2, I will have 6 moles of water bonded to it. So that's how you do 5. You're going to work 6 the same way. Number 7, they are giving you the mass that's going to go here. They're giving you the mass that goes here, but they're giving it to you in a percent. So you just have to change the percent sign to a G, and then set up 2 T-charts and put the information in each T-chart. And on number 7, it's a percent composition problem, and you're going to take the mass of 5 water molecules divided by the mass of that whole hydrate, the K2S plus 5 H2Os, and you'll get a percentage for water. So if that doesn't help you out, just give me a call. I'll be up to at least 11 o'clock tonight. Bye.